So we've learned about many different type of crystal structures and methods to analyze these crystal structures. Okay, just keep in mind one thing: your actual material that you're going to analyze is going to be very different from the crystal structures that we have learned. Okay, why is it so? Because what we have learned are some ideal forms. Okay, what we have learned are ideal crystals. Okay, in nature actually what you're going to find are real crystals. What are real crystals? Real crystals are the crystals which are having certain kind of deviations from the ideal crystals that we have analyzed. Okay, so there would be certain defects or imperfections due to which you have very great variations in the theoretical properties that you are going to observe from observing the ideal crystals. Okay, your actual properties of the crystals are going to vary with respect to the theoretical properties. Okay, so let's just say that you've calculated the density of a certain crystal to be this much. However, when you've actually calculate the density of the material in hand, you would find that this is 100 times lower. The reason is the crystal has having certain type of defects due to which its density has become lower. Okay, so in nature what you find are real crystals which deviate from the symmetries and organization of atoms in ideal crystals. Okay, so these deviations are in the forms of defect or imperfections. Okay, we are just going to see certain type of defects. Basically you can have a defect which could be a point defect, okay, a line defect, okay, an area or a planar defect, okay, and a volume defect. Okay, you can have any of these or combination of any of these present in your ideal crystals, which gives rise to your real crystals. Okay, so point defects over here, these are localized defects around a single atom. Okay, so if you have a defect which is localized, which is present only near a single atom, then that would be a point defect. Okay, your line defect is a one-dimensional effect. This is a zero-dimensional effect. Your line defect is a one-dimensional effect which is basically due to misalignment of atoms. Okay, so if you have misalignment of atoms, then what you get is dislocations, which are basically your line defects. Okay, your area and planar defects are your two-dimensional defects. Okay, so let's just say that you have a ABC layer. Okay, you have a CCP packing, okay, or a cubic closed packing kind of a structure, and instead of having ABC, you have ABC, AB, ABC. Okay, if one whole layer becomes missing, then that type of defect is a area or a planar defect. Okay, so entire plane of atoms over here are missing, which results in a area or a planar defect. Okay, and finally we have volume defects. These are the defects which are present over a large region. Okay, your point defects are localized defects which are present over a very small region limited to the vicinity of a single atom. Okay, your volume defects are defects which are present over a large region of the crystal. Okay, so let's say if you have a crack in the crystal, okay, or if you have foreign atoms over a large area of a crystal, then what you get is a volume defect. Okay, so this is a three-dimensional defect. Okay, so point defect